Okay, so we're going to be talking about significant figures now. We kind of mentioned this word a little while ago, but significant figures, now that we've talked about accuracy and precision, it indicates the precision of a measurement.
All right, so think back to last video real quick. Percent error was all about accuracy. Significant figures are all about precision. I'm going to put SF up here because I always use SF because I'm lazy. My handwriting's bad.
Yeah, now, see, the thing is in chemistry, we have different instrumentation. And so different instrumentation means that you're going to have basically different precisions.
Correct.
And so we need to actually pay attention to the digits that we record.
Right. So recording significant figures. Sig figs in a measurement include the known digits. So we know, okay, so let's look at this paperclip. We're going to use this this paperclip example to kind of go through this definition. We look at this ruler. We know it's at least 2 centimeters long. How do we know? Well, it's past the 2.
Past the 2. It's
That's
between
a
the
known
2 and the
digit.
3.
I'm going to put a K for known. All right, now we say, okay, 0.1, 0.2, 0.3.
Go ahead and click on it. You'll get a line. Hit the click. Okay. Oops. Oh, it's yellow.
Sorry.
There you go. Okay. So Mr. Freeman's kind of following that down. So we know it's between 2.3 and 2.4.
Which means it's got to be at least 2.3.
Yep.
He's a known digit.
All right.
The rest of our definition says plus a final estimated digit.
Well,
here's where people have lots of
Just a
fun.
minute. Can't I just estimate to 2.4?
No, because what if it's less than 2.4?
So estimating's not the same thing as rounding?
No.
Ooh.
Estimating means, and here's where people kind of get to have a little bit of fun. There's a range, shall we say, of digits you could pick. I personally, now my line's not the greatest. I personally would estimate this at 2.35 because it looks like it's about halfway. My line's a little bit thicker than it really should have been. I would estimate it 2.35.
What if I said 2.37? Who's right and who's wrong?
We're both right. That's the cool thing.
That's the cool thing.
And that's why we need significant figures, is because there's an estimate in every balance. Even if it's from the same company, every balance is slightly different. All these different things, when we talk about them in class, all the different things that affect how a balance works. Because of that estimate, there has to be a standard way to take care of that estimate.
Right.
And that's what we're going to look at in this video. And the next one, how do we deal with it? And that's what's called significant figures.
Well, and especially when we're dealing with human beings, because when we're using rulers or we're using graduated cylinders,
You're reading it.
we are reading it and we're estimating where that line is falling, and how Mr. Friedman reads it and how I read it could be different. Both of us are going to say 2.3. because we know it's greater than 2.3, but that estimated digit is based on how you view it. And so what we're going to do really is we're just going to work on counting significant figures first. So,
and the last thing I wrote here, see that little range, that's probably where I would have accepted. Anything below 2.33, it's like, it's too close to, that would be saying it's too close to the 2.3 line. Above 2.37, it's too close to 2.4. If it looks halfway between, put 0.5. If it looks like it's closer to the other one, down, put 0.2. It's just kind of
the one thing
practice.
we won't take is 2.3
or
2.4.
Yeah.
Because you have to go one more digit past the known.
Yep.
And so we'll practice that in lab quite a bit.
Right. So let's kind of start doing this, and the easiest way we know to do this is just do a bunch of examples.
We have some rules for significant digits. And the first thing is you're going to count anything that's not a 0.
Yep.
So 3,456 meters. How many significant digits do you see there?
Well, it says non-zeros always count. So there's 1, 2, and I always do what I call checks and X's.
Okay.
Check means it's a significant figure. X's means not, because X always means no, it's not.
Okay.
I see 4 checks.
Right.
There's 4 of them, and I know Miss SW, you have a way to do it where you do, was it with the lines or the boxes?
Yeah, and I'll do that in class.
You do boxes? Okay.
Yeah, the biggest thing is we don't have to worry about numbers unless the number is a 0.
Yep.
We only have to worry about zeros when it comes to sig figs. So you count any numbers, any digits between 1 and 9.
That's the easy part of significant figures.
All right, now let's talk about the zeros.
Zeros can get a little special.
So basically, leading zeros. So when we say leading zeros, where are those leading zeros
Pretty
there?
sure leading zeros are the ones that lead. They're the ones in the front.
Right.
So that's these guys right here.
They do not count as significant figures. Part of the thing, Mr. Freeman, write that number in scientific notation. How would you rewrite it?
All right,
4.86
so we need 1, 2.
times 10 to the negative second. Notice
There's
we
no
did
zeros.
not include the zeros when we wrote it in scientific notation.
Something we didn't mention in the scientific
Mhm.
notation video is the other reason for it is because of significant figures. It wouldn't have made
Yeah.
sense when we said it then. It helps us with significant figures
Yeah.
because now we say, oh, 4, 8, 6. They're all numbers that are non-zero. There should be, this has 3 significant figures. Well, let's
Right.
do it down here. These guys don't count
Because they're leading zeros.
because they're leading zeros. These do. Hey, look, they match.
Right.
If you do it that way and they don't match, one of your answers is wrong, which means go
Right.
back and look at it again.
And in being significant, it doesn't mean that those zeros aren't important. They
They're called
are.
placeholders.
They're placeholders. I mean, they hold the place for the 4, 8, and the 6. But it's that 4, 8, and 6. It's really the 6 that tells you the precision of the instrument. So, and a good way to check it is if you put that number in scientific notation, do you include those zeros? If you don't count them as significant.
Yeah,
So,
an example I came up with once on why we still need the placeholders
Mhm.
is so you go to a store and you buy something and you're supposed to get $400 in change. Obviously, the 4 is significant,
mm-hmm.
but wouldn't you be pretty upset if they gave you $4 instead of 400? Those zeros aren't really part of anything. They're just
Right.
moving the 4 over to the hundreds place where it belongs. That's what they're doing. They're putting your digit, your significant digit, significant figure, if you will, where it belongs and keeping it in place.
All right.
Okay.
Okay, so let's look at another place where you can find a zero. You can find zeros at the beginning, in the middle, and at the end. So now let's take a look at what happens
This is
when
my
you have
favorite.
a zero in the middle,
We know the 1 and the 6 and the 7 count
because they're not zeros.
because they're not zeros.
We say captive zeros. Sometimes I call them sandwiched zeros. Always count as significant. So you can see Mr. Friedman wrote 4 significant figures there. He's going to explain his Oreo cookie.
It's my
Theory.
favorite one ever.
His-
Oreo cookie rule. This is
All
a
right.
rule. Okay, everybody knows the most important part of the Oreo cookie is not those stupid cookies on the outside. They're important. Okay, they're chocolate. Great.
Yeah.
It's all about the cream filling.
Mm-hmm. That's true.
C for cookie, C for cookie, C for cookie. Oreo filling is in the middle.
Mhm.
You better believe he's important too, which
Yes.
means he's significant, right? Because significant means important, if you will.
Mhm.
This is what I call the Oreo cookie rule.
Right.
And that's why. Because I like
So-
Oreos.
So a zero is significant if you
it's
find
in
it
between.
between. All
Because
right.
he's part of that measurement.
Okay.
Right, so we want to do it known value, known value, known value. He's the estimate.
Estimate is
Did
that
we
seven?
mention how you always know where the estimate is? Probably not yet.
I don't know. What do you think?
I don't think we did yet. If we said it always ends with an estimate, where does it always have to be?
At the end.
Got to be at the end. Your last significant figure is always your estimate.
Right.
So we did zeros at the beginning, zeros in the middle, or Oreo cookies.
Now zeros at the end.
And these are the hardest ones.
This is
Sorry.
this is the hardest. We always save the best for last.
That's right.
We call them trailing zeros. They are significant if you see a decimal. So that's a big if. So let's look at 9.300 liters.
Yep.
Okay, so we know the 9 and the 3 are significant.
Yep.
Now the zeros are the questions. If you see a decimal, you count them as significant because there's no other reason to put those zeros there unless you're showing
Correct.
precision of an instrument.
Correct.
Okay, so 9.3 is going to be a different precision basically than 9.300.
Okay. This always gets
Yeah.
lots of fun in class when we always talk about this.
Mhm.
In terms of mathematics, in terms of just sheer numbers, 9.3 is exactly the same as 9.300.
Correct.
In terms of precision and significant figures, in science, chemistry, physics, biology, etc., they are not the exact same thing.
Mm-hmm.
Significant, two significant figures. This is very low precision.
Because it is only telling you precision to the 10th. If you look at 9.300, we're going 10th, 100th, we're going to the 1,000th place value. And so that 0 is telling you that this instrument is precise to the 1,000th place value.
And that's money.
Pretty
Okay,
good.
that's an expensive balance that's
Got
going
it.
that far.
Okay. Hey, Mr. Freeman, can you put up, what if we have 9,300?
I mean, like this?
Yep.
Okay, well, we have
And
trailing zero.
Tell you what, put miles as put miles there.
We know the 9 and the 3 are good.
Mm-hmm.
Okay, we have trailing zeros. This says it's significant only if there's a decimal point. I don't see a decimal point,
I don't see a decimal point.
which means these don't count. Now,
Okay.
there's an argument I always receive. Well, there's technically a decimal point after the last zero. True.
Yeah, but I don't
there is.
see it.
As written.
Right.
I don't know if this is going to fit, but I'm going to write it anyway. Go with it as written, and by written we mean as typed.
Okay.
As it's written. If there's no decimal point there, there's no decimal point.
Right.
If there's one there, it's there. Always go as written.
All right. So let's take a look and tie all this together.
Let's simplify.
All right.
That looks like there's 4 rules, but there's really only 2.
We're just gonna look at zeros. You're gonna count all numbers as significant except leading zeros and trailing zeros without a decimal point. Okay? So leading zeros we don't count as significant. Trailing zeros we do not count as significant without a decimal point. And again, look at that 2,500. If you were to put that in scientific notation, 2.5 times 10 to the third
Meters.
meters.
Okay, so some practice. How about we do that?
Yeah. All right.
Same thing as last time.
Yeah.
Take a second, get on the screen, hit pause, give it a try, and then we'll give you the answers here in just a second. Okay, hopefully I had enough time to get those. We're going to go through these.
Okay.
All right. How do you want me to do this? Checks and X's? You want to do your box thing?
Do checks and X's.
Checks and X's. Okay, we know the 1 is good. We know the 7's good. Now, I see zeros in between, and when I see this, I see a double stuffed Oreo.
Yes. There we go.
Greatest invention ever.
Captive zeros, significant. Double stuff Oreo.
Double stuffed Oreo.
Double
baby.
stuff significant.
All right, so then we see the 0 at the end. Now, if we remember correctly, our rule said zeros at the end
With a decimal or
with a
significant.
decimal. As written, I see a 0, I see a decimal. I
There
said
we go.
those opposite of the way I was drawing, but that's okay. Should be
5 significant.
5 significant figures. You notice 5 matches up to 1, 2, 3, 4, 5 checks.
So we have 5 sig figs there. Okay, what about the 17.10 kilograms?
Easiest way to do this, and actually I'm going to take a second here and do this. I have a lot of students that like to do this when they get practice. They go through and they put a check above everything that's not a 0. Like they'll just go through and do all of them because then they don't have to worry about it because you only have to worry about zeros.
So we're looking for zeros with a decimal are significant.
If they're trailing. All right, so we have...
If they're trailing, thank you, yes.
We have
So-
4 check marks, 4 significant figures.
Okay.
You want to do the next one?
Yep. Sandwich zeros are captive zeros. Double stuff Oreo again.
That's right.
Trailing zero. Do we see a decimal?
This is not a decimal, guys. That's a comma.
It is. We'll try to make that very clear.
Yes.
So when we look at that number, 100,890 liters, we really are assuming they've rounded to the nearest 10.
Correct.
So we're
This
not going
is
to count
your-
that zero as
Here's
significant.
your estimate. Yeah, I'll do the estimates at the end. We'll
Yeah.
do this real quick.
Okay.
Okay, let's finish significant figures. The next one's pretty easy.
I
Hey,
love-
look, scientific notation.
Yeah, when your number's in scientific notation, even if there are zeros in it, they all count as significant. So we've
Correct.
got no zeros there. So we've got 3 sig figs.
Last one, or second to last one, excuse me. I see
Leading
leading
zeros?
zeros.
Not
Decimals
significant.
don't matter for leading zeros. They never
Correct.
count. They're just placeholders.
So 2 sig figs. And the last one, we have trailing zeros, no decimal, 2 sig figs.
Okay, last
Okay.
thing I want to do here before we end is I'm going to put an E by all the estimates.
Mm-hmm.
And this estimate goes here with the 9. My apologies. Estimate, estimate, estimate. Again, it's the last significant figure.
The last significant digit
Whatever's
is
last in your last significant figure, that is your
Estimating.
estimate. And that's why we have these rules is a standard way for everybody to estimate the same every time, which gives you more precision because then they're all close together. It doesn't tell you whether you're accurate, it tells you whether or not you're precise.
All right, I think that's good.